Hello everyone, this is James Shore with another test-driven JavaScript video. It is still July 11th. I'm recording picking up where we left off in the last video, where we had just finished getting continuous integration working manually, which, it took us all of 15 minutes? Pretty easy. And very easy to just keep on doing. I mean, the integration step is really just walk over to the machine, run pull, run Jake, done. And that's why I don't really get all the continuous integration servers. Now, they do make a lot of sense when you have very slow builds, but that is actually a problem. If your builds are really slow, you're going to have a lot of broken builds. You should never, ever have more than a few minutes to fix a broken build. And you should never have a case where you check in and think you're done, and then hours later you're told that your build was broken. It's not good. And I'm not just saying that. It takes a lot of work to have a fast build and to get to this state. But again, that's what this is about. Rigorous professional JavaScript, keeping our cost of maintenance low. And that is why we've been spending all this time on it. We're done with continuous integration. Now we can finally get some testing done. So let's do this. All right, so let's make a place for this server-side code to go. I like to have my source code in a source directory. And then from here, I think it makes sense to make a server directory. And then in here, we can actually have the file itself. So let's just call this server.js for now. And I like doing all my Git stuff manually. Yeah, I'm going to go change this template file real quick. I'll be back in a moment. Okay, I'm back. I went with a really straightforward little copyright notice here. I haven't put up a license.txt yet, but I will do that. Let's make a note to do that. So we've done that. We need to add a license.txt. I will probably do that off camera so as to not waste your time. Okay, so we need to get server-side testing working. First thing I want to do is just say this is a server. So there we go, server. And the way we do that is, there we go. So, okay, I think I've been putting this off long enough. We need to write a test. Now, of course, the question there is, what test framework do we want to use? And there are a lot of them out there. And even more than that, the ecosystem's changing pretty rapidly. I think that if we're doing professional development, then we have to expect that our software is going to live for a long time. And the choices we make now are going to come back to haunt us in 2 years, 3 years, 4 years, 10 years. And in 10 years, will the test framework we choose today still be there? Maybe not. Maybe it'll be a completely different version. Maybe it'll have a completely different API. So what I want to do, and I've never done this before in JavaScript, actually, I've never done it before in any language. What I want to do is set up our system so that it's test framework agnostic. In other words, I want to wrap the test framework so that when we change our mind, not if, but when we change our mind about which framework we want to use, because it's gone out of business, or been canceled, it's no longer supported, or something better has come along, or they've come out with a new version that's completely API incompatible with the previous one. I want us to be able to swap the framework out under the covers and not affect our application. Now, I've never done this in any other language because no other language has been in so much flux as JavaScript is. It's evolving so rapidly that I think we have to do a lot to protect ourselves from other people's code. So I'm not sure how to do this. So I think the first thing I'm going to do is just do a little research. I'll just pick one of the frameworks, and then we'll start using that. But then what I want to do is I want to get that framework totally abstracted out so that we can swap it out under the covers. And I think we actually are going to want to do that swapping out. So we're going to choose a framework, we're going to abstract it, and then swap out a different framework to make sure the abstraction works. So that's my idea. We'll see how that goes. Anyway, I'm going to go off and look at frameworks and be back in a bit. See you soon. Okay, I'm back. So I went through my list of potential test frameworks, and I narrowed it down to 4. That's Jasmine, Mocha, NodeUnit, and Buster. And I think the 2 that have the most promise for me are Mocha and NodeUnit. I actually have used both of these before. They're very different tools, but I like both of them. Jasmine, it's entirely BDD based, and I actually am not a big fan of the BDD style. It's pretty verbose, and I'll come back. I'll describe that a little bit more in the future. So that was kind of a turnoff for me there. Mocha looks good. It's perhaps, and I really like the selection of test reporters. It also has sort of a BDD bias, although it does support multiple APIs. But what I really want to do is, so the reason I don't like BDD, and I should correct that. I don't have a problem with BDD. BDD, for those of you who don't know, is behavior-driven development. And it came along originally as a way of describing test-driven development in classroom, when in training, to help people understand how to do test-driven development better. Now, and I should be clear that this is my interpretation of the history. It's a bit contentious in the Agile community, so don't take my word for it. Go look at what the founders of BDD, like Dan North, say. But my impression is that BDD started out as test-driven development using the word should instead of the word test, and the goal there was that language helps you understand. The language you use influences your behavior, and using the word should would help people understood that tests were, in addition, a way of testing the application, also a way of describing how the application should behave, or specifically how specific units should behave. Now, test-driven development was always about describing the interface of the code you were testing. It was always about how the application and how the unit should behave. BDD attempted to make that more obvious. Now, it got some flack. People said stuff like, well, BDD is just TDD with a B, and why are you doing this? And there's no real advantage. And it's morphed quite a bit over the years from basically being TDD with the word should instead of the word test to becoming more of a very documentation-centric approach to doing testing, in that BDD frameworks often try to have automatic documentation generation. Some like Cucumber try to allow you to write documentation that is then later automatically tested. And all of that's really interesting and, in my opinion, not worth the cost of entry, because when you get this emphasis on the test acting as documentation like you do with BDD, that comes at a cost of being rather verbose. If I'm writing a test using test-driven development in a TDD framework, I will typically have one test method test one concept. And if it takes multiple assertions to test that concept, then I'll just put multiple assertions in that class. I tend to be pretty informal and not too rigid about the way I do my testing. So I want to have comments. I want what the BDD people put in the test name, I want to put in the asserts. And what they put in the describe, I want to put in the test name. And if that doesn't make sense, I'll just demonstrate it coming up. But if you are familiar with BDD and you really like BDD, then the reason I'm using TDD, or I prefer the TDD style, is I think it's more compact, and I don't need the documentation, because I think the test should be written to be readable documentation to programmers. And my experience is that customers, business people, rarely, if ever, read BDD documentation. It's a nice ideal that just doesn't happen in real life unless those business folks are also programmers. And even then, I don't see I don't really see them doing it. So anyway, long story short, BDD is a fine approach. It has an emphasis on creating documentation that I don't find valuable. So and the result of that is that because it has that emphasis, it uses this fairly verbose structure that I would rather avoid. So, but Mocha is an option. It does have a TDD interface. I'm just not so sure that it will give me a true TDD style. When I've used it before, I used it in the BDD style, and I did notice that the built-in assertions just didn't have the ability to put comments in them, put text in them, or at least I didn't see anyway. So that was a real downer. Now you can use any assertion framework with Mocha, and I do like the reporters, the tools, the output it provides. So I might end up using it. The other one I've used, Node Unit, very simple, straightforward. I like that one too. Buster.js is the fourth one I've investigated, and it's pretty immature yet. It's being done by Christopher Johansson, who wrote Test-Driven JavaScript, the book, and I have high hopes for it, but it's still pretty immature. So I'm going to pass on that one as well. So to get started, I think let's go ahead and use Node Unit, and because if for no other reason that it's really easy to run, and see if we can abstract that out so that we can have any framework, and let's try to use Mocha as well. I don't know if this abstracted out idea is actually a good one. We will see. So that is the end of this episode. Next episode, we will pick up by putting Node Unit into place and see where it takes us. Thanks for watching, everybody. I will catch you next time.